So as you saw there, I have a cube which grows on certain beats within a phrase and changes its material or changes its color on every beat of the phrase. I've achieved this using a quartz clock, and I'm going to show you how to do it now. Firstly, in the level blueprint, grab the quartz subsystem and create a new clock. You'll want to give this clock a name here to let other actors using the quartz system know which one to subscribe to. Then, for my clock settings, I'm going to promote the settings to a variable and set the number of beats to 7 to count in 7/8. Next, we can promote the output clock to a variable to have access to later, and we set the beats per minute. Finally, I'm going to create an audio item to be loaded for use later on. I will create a debug to start the clock, and in this line I will then make a custom event which will fire on every possible quantization option: beats, bars, and incremental note values. Don't worry, we can select from this individually with a switch statement later on. Next, we make a quantization boundary and a play quantized node. So when we play the music, it will know to not start till the next bar to make sure everything is synced up. Oh, and don't forget to actually take the clock as the object we want to subscribe to the quantization events. Next, we're going to create an actor blueprint that's going to be reactive to our music through Quartz and Metasounds. We need to get the handle for our clock. This will be the string that we named it in the level blueprint. Create a custom event and subscribe to all quantization events. Next, from the event, I'm adding a set material node and then creating an array of materials to be selected from. I'm going to set the current beat as an index to use to search for the material that we're going to use. Here, I'm creating an interface so we can have the direct callbacks between the two blueprints. Back in the level blueprint, I now make a switch to trigger every beat, but then create a boolean OR statement to check if beats 1, 3, and 5 are playing before triggering the code directly. On these beats, I will trigger a beep, which I will make later with the Metasounds, and then a pulse call to send to the actor to tell it to scale to the size of whatever beat the quartz clock is currently on. Use the class settings to add the interface to your two blueprints, and don't forget to actually name an event call so that it can appear in your BP. Here I make a wee mistake. I add an event call rather than a message, so this isn't being sent through to other blueprints. I fix this later. Back in the actor blueprint now, I set actor scale and connect the beats and add a debug to show it working as a vector. Now it's time to create the sine wave beep. I get the exact frequency for a B flat here, which is in the key of C minor, which is the key I'm using in my array of string parts, which I'll be adding in the next metasound. A little bit here about this next part I'm going to do. So any piece of music would work in whatever time signature you've set your quartz clock to. But for me, I've made a kind of modular piece of music. I've made a string part which is the same but is starting on different notes, and I'm going to make a meta sound which picks randomly which note to play next. So here we go. First thing here is you will need audio files that are the correct BPM and time signature, but also, if like me, your audio files have tails for better transitions when looping, you will need to mark their exit cues. Reaper lets you export audio files with markers that will have an ID number based on how many markers there are. We can make a meta sound here that will loop playback of audio files, doing a random selection for each loop. But by using two wave players, I can let the tail of one finish while the next one starts. Important notes here are, since this is music, you should use the Metasound setting to change the output to stereo. And you should use trigger compares to check for the number of exit cue, -6. You can check this by using a print string if you don't know. Finally, the trigger input should be set as deferred reference. This ensures that the metasound fully executes before triggering the next audio segment. If you didn't have this, then it would create an infinite loop in the code, and it would just throw errors. Here I forgot to create a second random get for the array, so the number it randomly selects is the one it uses for both wave players. To fix this, just simply use a second random get off the same execute pin. Let's add the strings and the beep to our level blueprint. you'd like me to dive deeper into anything to do with quartz clock or meta sounds and modular music, or even how to make the modular music stems, then please just let me know in the comments, and I hope you've enjoyed. Thanks for watching.